Welcome to VINDAL'S Academy. Let us x-ray part of this application of differentiation. I know it's a very big problem to many students and teachers. Watch me as I solve 1 to 30 questions. Don't forget to hit the subscribe button and also share this video. For those of you writing the exam, please comment where you're watching from, the name of your school, and the exam you're preparing for. And I'll be making more videos for you. Let's start. The first question said, find the gradient of the curve y equal to 3x squared plus 2x minus 5 at x equal to 2. So I'm going to say that whenever you hear this word gradient or you see the word gradient, it simply means dy dx. And we are going to solve this. This is going to be 6x plus 2. I am sure coming here means you have done differentiation 1, 2, and 3. Then at x equal to 2 simply means dy dx is going to be 6. Anywhere you see this x, you put the 2 because they already said that x is equal to 2. So this is going to be 2, cover in bracket plus 2. 6 times 2 is going to be 12 plus 2, which is going to be 14. That is answer to the number 1. Number 2, the start I should find the equation of the tangent to the curve. And to do that, all we need to understand is that the tangent, when we talk about the tangent, it also means dy ds, but at a given value of x to be 3. So that means I'm going to have 2x minus 4, which is going to be equal to 2 bracket 3 minus 4. Remember, x is 3 at that dy dx. Therefore, I'm going to have that this is going to be 6 minus 4, which is what? 2. Now, this is the y dx, or m, like many of you see gradient, which is equal to 2. But this is at x equal to 3, remember. But know that when we are talking about this, we have only x value. We need to find its corresponding value of y. So I'm going to substitute this bar into this whole equation. So I'm going to have y is going to be equal to 3 squared minus 4 bracket 3 plus 1. This is going to be 9 minus 12 plus 1. Everything is going to be minus 2. Therefore, I have a coordinate. The coordinate I'm having is going to be given as 3, minus 2, because this is the coordinate. Now, remember, we have found our gradient as m is to be 2 at this given coordinate. So all I need to do is to bring the equation of the equation for finding the equation of a straight line, because this is a straight line. Tangent is a straight line. Therefore, that equation is always given as m is given as y minus y1 all over x minus x1. If only one point is given, in this case, only this point is given. So what I'm going to do is, the dy dx is already given as 2, right? So I'm going to say 2 is going to be equal to y minus, y1 is minus 2. This is bracket minus 2 all over x minus 3. So this is going to be 2 is going to be equal to y plus 2 all over x minus 3. And lastly, I'm going to clear this bracket. I'm having y plus 2 is going to be equal to 2 bracket x minus 3. Therefore, y is going to be equal to 2x minus 6 minus 2. So y is going to be 2x minus 8. This is the equation of the line we are asking for here. If there is anything you do not understand, please try to pause the video and watch again. Moving to the next question. The next question says, a curve is given by this function y equal to 4x cubed minus 6x squared plus 2. Say find the stationary points. Remember, stationary points, not stationary points. Now, when we talk about stationary point is the point where a curve is momentarily at stop. It may be at the maximum. This is the maximum, or it could be at the minimum here, which is called the minimum point. Whichever point it is, I know that any of this maxima, dy dx is equal to 0. Even at this point, to dy dx is equal to 0. So that is the stationary point, right? Now, how do we do that here? What we are going to do is to first of all find dy dx and equate it to 0. So I am going to say that dy the x is equal to 4. This is going to be 12x raised to 2 minus 12x. Now, at the y the s equal to 0, I'm going to have 12x squared minus 12x equal to 0. I'm going to find the value of x. So factor 12x bracket x minus 1 equal to 0. So all I need to do is to find the values of x and substitute them back into the equation to find the corresponding values of y. So this is going to be x is going to be 0 or x is going to be equal to 1. Remember, all you need to do is to say 12x equal to 0, find the value of x for the first one, and then say x minus 1 equal to 0 to find the value for the second x. So these are the two x values we have gotten. To get its corresponding value of y, go back to the original equation. This is y equal to 4x cubed minus 6x squared plus 2. The first one, y is equal to what? Y is going to be equal to 2 at x equal to 0. If you substitute x as 0 in this equation, you have y as 0. Then at x equal to 1, then y is going to be equal to 4 bracket 1 all raised to 3 minus 6 bracket 1 raised to 2 plus 2. So this is going to be 4 minus 6 plus 2. And at this point, y is going to be 0. Therefore, I have two coordinates. The first point is that is going to be at x. If x is 0, y, if x is 0, when x was 0, y was 2. This is the first point. And then another point is when x is 1, y was 0. So when x is 1, y is 0. So these are the stationary points for this equation. Remember, it's a cube. It's a kind of it's a kind of a cubic function, and it's going to be like this, right? So this is the first stationary point, and this is another stationary point. That is how to find those points here at x equal to 0 and 1. All right, moving to the next one. Okay, they say determine the nature of the stationary points in Q3. To find the nature, when we talk about nature of any stationary point, the question is it maximum? Is it maximum or is it minimum? That is the question of nature. In the sense that if you look at this equation, the equation was given as 4x cubed, minus 6x squared plus 2. If you look at this equation, since the coefficient, this leading coefficient is a, is greater than 0, it's going to be like this. So you see, the nature is that there exists a maximum and there exists what? Local minimum. It's always this given as maximum and minimum. So I'm not going to sketch this, but I will just find the nature. So how do I do that? All I'm going to do is to do second derivative. So I'm going to find the square y all over the x squared. If this my value is greater than 0, I will determine what I will call it, which I will tell you later. Then if my second derivative is less than 0, then I will know what it is. Okay, so let's start. First of all, let's go back to the original derivative. Okay, what we had was 12x squared minus 12x. So y prime is something as the x. So it was given as 12x squared minus 12. So y prime, y double prime, or the square y all over the x squared is going to be 24x, right? Oh, sorry, that was 12x. 24x minus 12. So this is the second derivative, okay? Now, all we need to ask ourselves is, at what point? Now, if we are going to choose our maximum point, remember we have chosen our points. The points we chose were 0, 2 and what? 1, 0. These are the points we have chosen. So this is x and this is x. So I'm going to, let's choose the first point. The first point is 0 and 2. If I substitute the value of of the square y, the second derivative as x. So at x equal to 0, you said that dy is going to be equal to what? Minus 12. What does it mean? It means that it is less than 0. That means this is the truth. So if my second derivative is less than 0, it means it is decreasing. That means this is the point we are talking about. So it means it started from the maximum and it is decreasing. Therefore, the nature is maximum. So at x equal to 0, I have what? Maximum. So the nature is what? Maximum. Okay? But then if I now choose x to be 1, if I put x to be 1 here, I'm going to have y double prime is going to be greater than 0. That means it is minimum. Therefore, at x equal to, at this value, this first value now, it is minimum, which is 1, 0 is minimum here, and this one is maximum, which is 0, 2. Therefore, the nature, he said, determine the nature of the stationary point. This nature of the stationary point is this. There exists maximum at this point. 0 and 2 is the maximum. That means it is at the heel, whereby 1, 0 is the minimum, which is the down part. Okay. Now, number 5. Number 5 said, find the value of x for which the curve has a turning point. So turning point also means that dy dx must be equal to 0. Then at that point, we can find the values of x, because they say we should find the value of x for which this curve has a turning point. Turning point, remember, turning point may be turning from up down, or it is turning from down going up. So that means it is decreasing. This is decreasing point, and this is increasing point. Let's find out. So we say that dy, the x is going to be equal to, that will be what? 3x squared minus 18x plus 24. That is it. Okay. So, but in this case, dy ds at any turning point, dy ds must be equal to 0. Therefore, I'm going to have that 3x squared minus 18x plus 24 is equal to 0. Now I have to factorize them, but let me break them down, because they all can be divided by 3. So I have to break them down so that I can be working with smaller factors. I have x squared minus 6x plus 8 equal to 0. Now, what are the factors of 8 that will add to give you minus 6? It's going to be minus 4 minus 2. Therefore, I'm going to have x minus 4 and x minus 2. This simply means that x is 4 or 2. Now, these are the values of x at this turning point. So at that turning point, we have x and 2. That is my turning points. Okay. Moving to the next question. Number 6, the question said, a particle moves so that x days, find the velocity and acceleration. Remember, I don't want to be wasting time because of the time of this video will be too large. So find the velocity. Remember, if this is s, t raised to power 3 minus 6t squared plus 90. Now, this is the distance. To find distance, remember, to find velocity is something as change in distance all over change in time. Or, that should be change in time, not change in x. Change in time. Therefore, simply means to find velocity of this particular equation, I need to find the derivative of this equation. So the s, the t is going to be what? 3t squared minus 12t plus 9. This is the velocity, because you asked me to find the velocity. So this is the velocity. Now, to find acceleration, remember, acceleration is something as change in velocity all over change in time. Therefore, I have that velocity is given as 3t squared minus 12t plus 9. Now, to find my acceleration, I'm going to say dv dt. To derive this, I'm going to have 6t minus 12. This is the value of acceleration, and this is acceleration. Now, moving to the next one, number 7. Number 7 says, find when the particle in question 6 is momentary at rest. So if you say momentary at rest, it means that the velocity must be 0. That means I'm going to go back to say that the s dt must be equal to 0. And the when means at what time. So let's go back there. So look at this equation. I'm going to use this equation. So at what time? All right. So let's go back. Therefore, I'm going to say that 3t squared minus 12t plus 9. This is what we got as velocity. Is equal to what? Velocity. So at rest, velocity must be 0. Therefore, I have 3t squared minus 12t plus 9 is equal to 0. Now, remember, I have to break this equation down like I did initially. Divide by 3, divide by 3, divide by 3, divide by 3. I'm doing this because all of them can be divided by 3. So I have t squared minus 4t plus 3 equal to 0. So what are the factors of 3 that will add up to give me this? Minus 3, minus 1. So I'm going to open two brackets equal to 0. I'll say that t minus 3 and t minus 1. Therefore, t is equal to 3 or 1 seconds. Remember, so when? So it's either at 3 seconds or at 1 second. Number 8. Let's see if we can get to number 10 before a particular time. Say a rectangular sheet has area. Okay, this is the area of the sheet. Find the maximum area. How do we find the maximum area? Remember, at maximum, the x must be equal to 0. Therefore, at maximum, maybe upper maximum now, the s must be 0. So the x equal to 0. But I am not having y and x. What I have is a and x. Therefore, the x is equal to 0 at maximum. So what should I do? I will say that the x is going to be given as what? Okay, first of all, open the bracket. When I open the bracket, I'm going to have 12. So I cannot, that would be mathematically wrong to do that. So first of all, I'm going to find a. A is going to be given as 12x minus x squared. Therefore, the x is going to be 12 minus 2x. Now, when it is 0, therefore I'm going to say that 12 minus 2x is equal to 0. Therefore, x is the same thing as 12 divided by 2, which is what? 6. Now, I have gotten 6. 6 means at that maximum, the value of x. So if this is a curve, right now, okay, this is the maximum. Let me highlight it with this color. This is the maximum. So at that maximum, they are saying that the value of x is 6. This is x value, and this is a on the vertical. So I don't know the value of a when it is maximum, and that is area, and that is what I'm looking for. To get this, I have to substitute the value of x into the original equation, and this is the original equation. Therefore, I'm going to say that a is equal to 12 bracket 6 minus 6 squared. A is going to be equal to, if you factor out like here now, I can use this place so that it will be easier for me. So I'm going to have 6 bracket 12 minus 6. So A is going to be equal to 6 bracket 12. 6 minus 12 minus 6 is 6. Therefore, area, which is maximum, is equal to 36. This statistic is going to be unit square at x equal to 6. Number 9. So find the rate of change of y of 2x squared plus 3x at x equal to 4. So at this point, the rate of change, whenever you talk about rate of change, just differentiation because that is calculus. So I'm going to have that dy, the x is going to be given as what? 4x plus 3. Then at x equal to 4, so I'm going to have, this is going to be that y prime is going to be 4 bracket 4 plus 3, which is 16 plus 3, which is 19. All right. So let's go to number 10. Number 10 says, find the rate of change find the maximum of this. So find the maximum or minimum. It must be maximum. There is no minimum here because okay, let's say okay, let's solve. In this case, I'm going to say that dy dx. I'm going to have that dy dx. They say find the maximum or minimum. So we're going to find out whether it is actually maximum or is minimum. So let's go. This is going to be what? 2x minus 6. Okay? Now, okay, so if I do that, I am now going to find the value of x. If x, because sorry, this is what I'm supposed to do. I was thinking about maximum is 0, all right? So we have that the y, the s is supposed to be 0, whether it's minimum or maximum. Changing x, changing y with respect to change the s should be 0. So I have 2x minus 6 equal to 0. Therefore, 2x is equal to 6. So x is 3. So x is 3 at that point, whether it's maximum or minimum. What I'm saying is, if this is the graph, if it is actually maximum and this 3, this will be 3. Or the curve was actually like this, then this place will also be 3. So let me clear up. I was just using that to create the picture for you to understand what we are doing. It's not just solving maths, we are doing application. So at this point, I'm going to substitute. I'm going to do another derivative. So d square y all over the x squared is going to be equal to, I'm going to differentiate this. So I'm going to have 2. Now, if you check very well, d square y all over the x squared is greater than 0. Whenever it is greater than 0, what does it mean? It is increasing. Now, increasing means what? Minimum. So this is actually what? Minimum. So if it is minimum, what should be the points? What should be the value of at the minimum? Therefore, if I go back, I will going to say at that minimum, x is equal to 3. I will substitute x as 3 into this. What value am I going to have? Let me say, I'm going to say that y is going to be equal to 3 square minus 6 multiplied by 3 plus 10. And this is going to be 9. 9 minus 9. 9 minus 9. No, that's 9 minus 3. Because this is 9. You have 9 there. 9 minus 18 plus 10. I'm saying 3. So this is going to be 19 minus 18, which is 1. Therefore, x is 3, y is 1. So the coordinate is 3, 1. And it is minimum, not maximum. Remember, they say find whether it is either, you say find maximum or minimum. So our answer is minimum. And at the point 3, 1. The next question here is, it said a ball is thrown and its height after t seconds is h. Okay. So we are given this from, let me go back to my favorite white. So what we are going to do is to find the h, the t. So, and that is going to be what? 20 minus 10t. Now, if I am to find this maximum, it must be 0. So the h, the t must be 0 at that point. So I'm going to say 20 minus 10t is equal to 0. So that means that t is 2 seconds. So it was 2 seconds. Now the question is, what is the maximum height that at that point? So if this is a graph of the curve, so maximum, the thing move like this, maximum, that means this is time, t in seconds. So this is 2 seconds. That 2 seconds is what? Is maximum. But what height? Because this is height in meters. So what height will be corresponding to that too? You substitute this thing back into this equation and that will give you the answer. So say h is equal to 20 multiplied by 2 minus 5 bracket 2 squared. So this is 40 minus 5 times 4, which is 20. Height is going to be what? 20 meters. Number 12, they said Find the gradient of y equal to 3 over x at x equal to 2. So to differentiate this, I'm going to have that dy dx, because gradient, I'm doing dy dx because gradient is dy dx, and this is going to be 3 3 all over. How do I define this one? How am I going to do? Wait, I'll handle it. Let me show you what to do. I don't want to follow this approach so that at least I can teach others. So this is why it's going to be 3x raised power minus 1. Do you understand that? It's the same thing as saying 3 divided by x. Now, the power of x is minus 1. So say dy dx is going to be equal to minus 1 bracket 3 x raised power minus 1, which is going to be minus 3 x raised power 2 minus 2, which is something as saying dy dx is going to be minus 3 all over x squared. So at x equal to 2, I'm going to say that dy dx is going to be minus 3 all over 2 raised power 2, which is going to be minus 3 over 4. All right. Number 13. You say find the rate of change of volume of the sphere with respect to radius. Okay. So I'm going to have that dv dr, which is going to be equal to 4 over 3 multiplied by 3, because r is the one I'm using to multiply. It's going to be pi r 3 minus 1. So this will cancel this. I'm having 4 pi r raised power 2 is going to be v prime, or dv dr. All right. So the answer is total surface area. I think that is of a sphere. Total surface area of a sphere. If you differentiate volume of a sphere, you have its total surface area. So the next question is going to be number 14, and this is trigonometric. He said find dy dx of sine. When you differentiate sine, you have cos x. Simple. Now they say when x is pi over 4, that means this is going to be cos pi over 4. All right. Now, what is pi over 4? Remember, pi is 180 degrees. If you divide 180, this is 2, this is 90, which is 45 degrees. Now, 45 degrees is something as root 2 over 2. Therefore, dy dx is going to be cos pi over 4. Cos 45 is root 2 over 2. So the whole answer is going to be root 2 over 2. Number 15. So I would like you to try number 15, because we'll solve for a question that has to do with finding the stationary point of a function. So I would like you to try to solve this question and not just be in the class. I want you to participate in our lesson. So, and tell me your answer. I'm sure, just tell me your answer. Let me know what you get at that number 15. Then let's move to number 16. He said that a time feels such that v equals 3t squared plus 2t. So find the rate of increase at t equal to 4. All right. So in this case, I'm going to have that dv dt is going to be equal to 6t plus 2. Now remember, they said at t equal to 4. So I'm going to say that dv dt is going to be 6 multiplied by, when I see this t, I put 4, because that's what they said we should do, plus 2. So we now have 6 times 4 is 24 plus 2, which is 26. So it's going to be 26 unit square per second. All right. So that is the rate, dv dt. Number 17. Number 17 said, if y equal to x raised by 4 minus 8x squared, find the stationary points. Oh, this is another question. Another question on stationary points. Okay. Since I have given you one to try, so let me solve this one. First of all, I'm going to have stationary point is going to be dy dx is going to be equal to 4x cubed minus 16x. So after getting this, I'm going to factor out. I'm going to have that 4x bracket x squared minus 4 is equal to 0, because dy dx must be 0 at stationary points. So for that reason, I'm going to find the values of x. So I'm going to have that 4x is equal to 0. That simply means that x is equal to 0. Now, after that, I'm going to have that x squared minus 4 is also going to be 0. That is all. Then that means this is difference of 2 square. I'm going to have x plus 2, bracket and comma, another bracket, x minus 2, all equal to 0. That means that x is equal to 2 or x is equal to minus 2. Therefore, all the values of x include x are 0, minus 2. Okay, I said minus 2 first, minus 2 and then 2. Or supposed to be written in ascending order. So I'm going to say that x is equal to minus 2, 0 and 2. So these are the stationary points of x. So you can also find the corresponding value of y. So I can also find the corresponding value of y. I can say that in this case, I'll say y is equal to minus 2 all raised to power 4 minus 8 raised in bracket minus 2 raised to power 2. So y is going to be equal to, this is going to be 16 minus 8. This is going to be bracket 4, right? So this is going to be 16 minus 32. Therefore, y is going to be minus 16. Therefore, the stationary point that is that minus 2, minus 16. This is the stationary point of the first one. So you know what I'm doing. Also substitute your own. Find the second coordinate. I have found the first coordinate. Find the second coordinate and the third coordinate of the stationary points. My intention is that so that you'll be part of this lesson, find those points and tell me what you got on the comment section. So let's go to number 18. In number 18, we say, find the nature of the stationary point in 17. Find the nature of stationary point in 17. All right, so I have also done question on finding the nature of stationary point. So you can also go back and check the video and also try to solve your own and determine what your answers are. So at x, if at x equal to 0, the stationary point is going to be minus 16. And since the square y divided by the x square is less than 0, therefore we are going to say that it is maximum. So try to solve your own and be part of the lesson. That's my intention, not just solving question and you are just watching, sitting down, enjoying yourself. Let's be part of the lesson. That is all. Because I've done something exactly like that, so you need to just follow the same pattern and do your own. Number 19, find the rate of change of y equal to ln x when x is e. All right, so in this case, we are going to say that whenever you say dy dx of ln, you're going to have 1 over x. Okay? 1 over x. And then they say when x is e, this simply means that the x is going to be 1 over e. That is the answer. All right? These ones are fresh questions. We've not done something like this, so it's very important we keep doing them. So in this case, we have dy dx. It's a find dy dx. I'm going to solve it using chain rule. I'm also going to show you the trick. Using chain rule, you are going to say y is equal to e raised to power 2x I'm going to say let v equal to 2x. Therefore, I'm going to say the v dx is going to be equal to 2. That means y is going to be equal to e raised to power v. That means, look at what I'm saying. What I'm saying is that I have already called this one v. So it is very right to write the equation like this because the power is already v. And I have found the derivative of v. So the next thing is going to say dy with respect to dv, which is going to be e v. So this is second derivative I'm doing here. Therefore, to find dy dx is going to be, check the pattern, dv dx times dy dv. If you check this very well, a situation, if you are looking for dy dx, you have to set a equation where, so that if you cancel this and cancel this, you still have your dy dx. Let me give you another example. If you have the p, the b, this must be equal to whatever you're going to have. Let's say the y must be equal to the b times the p all over the y. You see that? So that if you cancel this and cancel this, you're still going to have the p over the b. That is the concept. That is the principle. That is the pattern. All right. So in this case, I have come back to my dy dx, which is going to be equal to dv dx is what? Dv dx is 2, which is 2 times dy dv. What is dy dv? E raised to power v, such that dy dx is going to be the same thing as saying it's going to be 2e. This v is the same thing as 2x, so this is going to be the answer. Now, if you check this very well, that is a very special trick you can apply to this. The trick is simple. Differentiate the power. You have to multiply by everything together. Being differentiator is going to be e raised to power 2x. That's the answer. Number 21, it said a car displacement is s equal to 5t squared minus t cubed. Find its maximum displacement. Find its maximum displacement. All right. I'm going to solve this, even though I have done this before, but let me do it. So I'm going to have the s dt must be equal to 10t minus 3t squared. At maximum displacement, the s dt is 0. Therefore, I have 10t minus 3t squared equal to 0. So at this point, I'm going to factor out. So I'm going to bring out t. T is going to come out 10 minus 3t equal to 0. Therefore, t is 0 and t is going to be equal to 10 over 3. So these are two values of t. So I'll say t is going to be 0, 10 over 3. Now, what do? We are going to, substitute this back into this equation. Or, yes, I'm going to substitute them back into this equation to find their corresponding value. Because at maximum displacement, but then remember they've already told me maximum displacement. So let me take the second derivative. So I'm going to go back to this, this one. I'm going to differentiate this again. So I'll say d square x all over the t square is going to be equal to 10 minus 6t. Now, I have already found t to be 0. So let me substitute t to be 0 into the equation and see what I'm going to get. Or let me substitute 10 over 3 into this equation and see what I'm going to get. So because remember, this is going to have 2 turning points. So because the leading coefficient of this one is minus, it's going to start like this. It's going to start from here, down and up. So we have first and second one, but this is maximum. This is what we're interested in. So I'm going to use 10 over 3. So I'm going to have this the square s all over the t squared is going to be 10 minus 6 bracket 10 over 3. So this cancel, this is 2, which is going to be minus, I'm going to have minus 10, because minus 10 is the answer. So minus 10, it simply means that the square s all over the t square is less than 0. If a function is less than 0, we say it is decreasing, and that is maximum, right? So, and what will be the value of the maximum displacement is going to be us substituting this equal to this. We have 5 bracket 10 over 3 squared minus 10 over 3 all raised to power 3. If you simplify this expression very well, you're going to have that s is going to be 500 all over 27, which is something as 18.52 units. So this is the value of the maximum, and this is the value at the maximum, 10, 10 over 3. That is the value of the maximum. All right, so let's move to number 22. So find the slope of the function at this. I am sure you have tried this before. I'm sure you have done something like this before. So I'm going to allow you to try this to confirm that your answer is 8. Your answer is going to be 8. So confirm that is your answer. So let's go to next question, number 23. You say a rectangle has perimeter of 20 cm. Express its area in terms of x length and find the maximum area. All right, so what I'm going to do is, first of all, let's draw it. A rectangle has a perimeter, so let me draw this first. A rectangle has a perimeter of 20. Express its area in terms of length. Okay, so the length is x, and I'm going to call its breadth as y. Okay, so this is going to be 2x plus 2y is going to be 20. This is my first equation, because that is what it is. So I'm going to have simply put that y, so I'm going to say 2 bracket x plus y is equal to 20. That means that x plus y is going to be 2. If I make y the subject formula, I'm going to have, it is going to be 2 minus x. So can be 2 now, is 10. Sorry. So it's going to be 10 minus x. So this is the value of the equation. But area is going to be what? Area is going to be x multiplied by y, which is something as xy. Now remember, I am asked to find the maximum area. Find the maximum area. All right, so what I'm going to start doing is to substitute the value of y into this area. I'm going to say that area is going to be x multiplied by y is 10 minus x, right? Because it must be in terms of x. This is x. They didn't tell us y. I am the one that brought in y. So I have to, express this equation in order to eliminate the y. That's what I'm doing. So I'll have that area is given as x bracket 10 minus x. All right. Now, simply put, this is going to be 10x minus x squared. So what should I do in order to find my maximum? I'm going to say that the x is going to be 10 minus 2x. Now at maximum, the s must be 0. Therefore, I'll have 10 minus 2x is going to be 0. Therefore, x is going to be what? 5. X is 5. If x is 5, what will be the corresponding value of the maximum area is when I have to resubstitute this value into the expression in order to get what is the maximum value of this x. So what I'm going to do is to say area is going to be equal to 10 bracket 5 minus 5x. So area is going to be equal to 50 minus 25. So area, maximum area is what? 25 cm squared. So if the maximum area is 25 cm squared, therefore y should have been 5 as well. Because if you go back to this equation, if x is 5, then y must be 5 in order to get this 10 as 10. All right, so let's move to the next question. I say find the derivative of y equal to 1 over x squared plus 1. If I express this as a quotient, I can use quotient method to solve this. Or I will not solve it as quotient. See what I will do. I'm going to say that y is going to be equal to x squared plus 1 all raised to power minus 1. I'll use chain rule. So what I will do, differentiate the one inside the bracket first. So I'm going to have 2x. Then using the 2x, I will multiply everything being differentiated. I'm going to have x squared plus 1 raised to power minus 2, then times minus 1. So the y, the x is going to be equal to minus 2x bracket x squared plus 1 all raised to power minus 2. Therefore, everything is going to be minus 2x all divided by x squared plus 1 all raised to power 2. This is going to be my dy dx. So we are going to number 25. Number 25 said the slope of a curve is dy dx, and which is equal to 6x minus 4. If it passes through the point 1, 2, find the equation. All right. Remember, this is a kind of finding the equation of a line. So all I'm going to do now is to say that is to find y, even though this is dragging us back into differentiation and into integration. What I'm going to do is we'll say that dy dx is going to be equal to 6x minus 4. I'm going to integrate them to get the original equation. So I'm going to have that y. If you differentiate this, I'm going to have y is equal to the integral of 6x minus 4 multiplied by the x. So this is going to be y is equal to 6x raised to power 2 all over 2 minus 4x, all right, plus c. So y is going to be equal to, I think this question, I'm not supposed to bring it here, but then no problem. So remember, it passes through the point 1, 2. So I'm going to substitute this value of x into this equation to find the value of c, which is the point it crosses the y-axis. Yeah. So I'm going to have that y is equal to 3, 1 raised to power 2 minus 4, 1 plus c. And remember that y is also supposed to be substituted for us to find c. Y is 2. So this is 2 is equal to 3 minus 4 plus c. So this is 2 is equal to 3 minus 4 is minus 1 plus c. Therefore, c is going to be 3. Then the equation I'm looking for becomes 3x squared minus 4x. In place of this c, I'll put plus 3. So this is the equation I am looking for. This includes integration, which maybe I wasn't supposed to bring it here, but at least you've been able to know how to navigate from a derived function back to this kind of function. All right, let's go to number 26. You should find where the curve is increasing. All right, so we are going to find where the curve is increasing. I think this is the first time we are asking you this kind of question. So we are going to find it. Where is it increasing? That means if it is increasing, that means it must be a minimum point at this point. So where is it increasing? So I am going to find that particular job by finding dy dx. So first of all, I'm going to say dy dx is going to be equal to 3x squared minus 6x. Now I'll say that 3x squared minus 6x is equal to 0. Therefore, we'll have 3x bracket x minus 2 equal to 0. That means that x is going to be 0 and x is going to be 2. So these are these points. And since is greater than 2, okay, so what I will do now is I've gotten the value of x. So since it's minimum, I have to take a second derivative. Let me go for the second derivative of this. So I'll say the square y all over the x squared is equal to 6x minus 6. Now let me substitute x equal to 0 here. I'm going to have that. Let me use prime so that it will be easier for me to write. So this is double differentiation. So I'm having minus 6 at x equal to 0. That simply means this double integration is less than 0. So it is less than 0 then. Then another point at x equal to 2, we are having that double is going to be equal to 6 bracket 2 minus 6. So double integration is going to be 12 minus 6. Then double integration is equal to 6. That means this one is greater than 0. So what we are going to say now is that it is actually increasing at x equal to 2. And that means it should be x is going to be greater than 2. The point where, because it's not going to be increasing at that same point at x equal to 2. It's going to be where x is greater than 2. And that is where it's going to be increasing. All right. So that is my answer for that one. Number 27. In number 27, I'm going to have that find dy dx of sine square. I'm going to use product rule to solve this. I'm going to say that let v equal to x squared. That means v prime is going to be 2x. Then I'm going to say let u equal to sine x. Then u prime is going to be equal to cos x. So I'm going to say that y prime, which is going to be u v prime plus v u prime. Now that means y prime is going to be, what is u? U is sine, this is sine x, multiplied by what is v prime? V prime is 2x, plus what is v? V is x squared. What is u? U is cos x. So this is going to be 2x sine x plus x squared cos x. So this is the answer for this number 27. Moving to the next. Number 28, say if y equal to tan x, find the gradient at x equal to 45 degrees. So what you need to understand about this question is that we need to have a standard for deriving or for differentiating tan x. So this is going to be dy dx is going to be equal to sec square x. This is what sec square s is going to be, and this is what is tan. So whenever you differentiate tan x, you're having sec square. But remember, we said that at x is equal to what? 45 degrees. So when I substitute x at 45, so I'm going to have, remember what is that? That simply means that if I have the y, the x is equal to sec 45 degrees all square. My answer is going to be 2. You can use your calculator to find that. So I have number 29, which is almost close to the end. So half cone. They say a cone volume is given as 1/3 pi r square h. If h is constant, find the v, the r. Okay, so in this case, h is constant, of course. So I'm going to have the v, the r is equal to 2 multiplied by 1/3 pi r. R is 2 minus 1 multiplied by h. So this is going to be 2/3 pi r h. Okay, because h is constant, so I'm not deriving that one. So this is my answer. And this is the last question. Say find the second derivative of this function. Second derivative means you first of all find the first derivative, then you find the second derivative. The first derivative is going to say that the y dx is equal to 3x squared minus 12x plus 9. So this is the first derivative. Second derivative is going to be, I'm starting from where I stopped. I am going to derive it again. I'm going to have 6x minus 12. So this is my second derivative. Thank you for staying to this point. 30 questions. And remember, there are some areas I ask you to try to solve. Please, I would like you to be telling me on the comment section what you got. If you're a student, tell me the name of your school, where you're watching from, if the video is interesting to you, and have a nice time. Remember, don't forget to hit the subscribe button, share this video to as many students you know, and let us wipe out this phobia. Enjoy your time.